Hi everyone, my name's Farhad. I work at TRC. My last name's Farahmand, so that's the name of the presentation, Farahmand. So I'm going to go over a few different projects that we've worked on in the last year that are related to electrification and energy modeling. Just a quick pitch. I was going to talk a little bit about a project that Abhijit is going to work on. For those of you who know Abhijit Pandey, he's looking for monitoring and verifying commercial ZNE buildings. So if you guys know of any of those that are kind of in construction or planned, we'd like to monitor and verify those buildings. So just let me know. I know we haven't talked about commercial. Okay, so I'm on slide 3, reach codes. So we're going to slide 4. I just kind of want to set the stage for what a reach code is. This is what we have been doing a lot for the last couple of years. Basically, a reach code mandates that buildings achieve energy performance that's higher than what the state requires, above the Title 24 state requirements. There's a way you can go about it, which is providing prescriptive guidance. There's a set of measures that you have to do above Title 24. Usually what we end up doing is a performance recommendation. So we do a package of measures and model them all together, see what that performance compliance margin is, and then a city would say, okay, we found that this is a cost-effective compliance margin to achieve. And we'll require this compliance margin, but you can do it however way you want to do it, whatever builder wants to do it. So it's like 15% better than Title 24, or there's an EDR target, an energy design rating target, which is a new addition to this CBEC software. When a city wants to adopt a REACH code, they need to submit a cost-effectiveness analysis to the California Energy Commission. And the California Energy Commission reviews that and says, okay, you're showing that you're requiring buildings to be a higher energy standard, but it's cost effective. So we approve it. And so that's a major step, and that's where we help cities a lot. And we provide that analysis to them. I was talking to Pete Kennedy the other day, and apparently there's one city, which I don't want to embarrass that city, but they haven't submitted that cost effectiveness analysis. They were basically going to require one developer to achieve this higher compliance margin. Their attorney was like, oh, you guys never submitted this analysis, so we're not going to do it. What are you going to do about it? And they basically can make me do it. So this is important to get approval from the California Commission. Yeah?
What is the standard of cost effectiveness?
I'm going to get into that.
Okay,
yeah. That's the next slide. Yeah, slide 5.
Before you go to slide 5, can you explain something on the prescriptive? The first bullet says exactly 3 measures, or 3 measures from 10 lists. What's the difference between those two?
So I think this is, Oregon has a point-based system where they have a big table of different energy efficiency envelope measures, HVAC measures, and if you do one, it gives you like 2 points or 1 point or whatever. And they say you have to get 15 points in order to build a new house or build a new building. So that's a prescriptive set of measures that they make you choose from, but they only make you choose some of those, not all of them. So it's not like you're doing an energy simulation and have to do a performance approach.
Right, so this is not about that. That's not about Title 24 then. Oregon.
Yes, that's about Oregon, but it's an option for Title 20. It's an option for a city. If they want to go that way, they can either do the prescriptive way or the performance way. And typically the performance way is more flexible because the builder can do whatever they want to, basically.
Could you mention at some point possible negative impacts towards electrification that could happen with if a certain REACH code is adopted?
Negative impacts. Well, so I'm going to be talking about some cost effectiveness findings that we had for electrification analysis, so maybe that's a good time to have that discussion. Okay. So, slide 5. The typical approach that we take is that we take a set of prototypes, prescriptive prototypes. By that I mean like we have a 2,700 square foot house, and it has all the prescriptive requirements that Title 24 has. So the R15, or what is it now? R19 plus 5 walls, high performance house. So R38 ceiling insulation, federally minimum efficiencies for their appliances. And then we apply energy efficiency measures in CBEC, and we see what their impact is, and we assess costs for those measures as well. So the measures that we can look at are constrained by very certain things. The first is preemption. So we don't really look at HVAC measures or domestic hot water measures. Those are federally preempted. If a city were to say you have to install a higher EER or SEER unit or AFUE furnace, then they could get sued because that's federally regulated. And that has happened. Albuquerque tried to do that, and they got sued by AHRI or another trade organization, and they lost, and they couldn't require those within their city. We don't typically, this is a Tile 24 reach code, so we don't look at Tile 20 appliances. We don't look at the efficacy. Lighting is covered by Tile 24, but it's all mandatory, so you can't model improvements in lighting, and it's all high efficacy anyway, so it's tough to get much better than what Tile 24 is requiring. A constraint is the prototypes that we're looking at, so we look at typically 2,100 and 2,700 square foot homes, or like a typical small office, this one story, or typical three-story office. But there's a variety of building types and sizes, and it's a constraint. We have to try to bound the problem in certain ways. And of course, the modeling software has certain capabilities. Some measures can't be modeled, so we have to assume savings through kind of some interesting ways, like Luke does, and also recommend that cities allow alternative compliance paths for those. So, like, for example, drain water heat recovery, it's going to be a 2019 compliance method in Tile 24. And it's going to be part of the software then. It's not part of the software in 2016. So we looked at the savings estimated through that code enhancement report, and we translated those numbers to 2016, and we're going to say, well, if your building is in this climate zone, then we recommend taking off 10 to 15% of your domestic hot water load, and then resumming your total calculation, and then you'll have your new compliance margin. Like, there's these workarounds that we would recommend to a certain jurisdiction that wants to adopt a certain compliance margin. That's not currently achievable through the current model. Okay, so what is the cost effectiveness framework? Is this B to C ratio, benefit to cost ratio. So that scale is showing that on one side is energy savings, and the other side is costs. So if the energy savings are greater than the costs, then the benefits are greater than the costs. And we have a B to C ratio that's greater than 1. The way we evaluate energy savings is through two ways. Time-dependent valuation. Who here knows what time-dependent valuation is? Okay, so, like 2/3. It basically assigns a dollar value for fuel used at every hour of the year based on the demand of that fuel for that particular hour. So if there's electricity that's in really high demand at a particular time, it's got a very high value to it. The other way we look at it is just through utility bill impact. So for a normal person who is getting this utility bill, is it going to be cost effective for them, for the end user? So we try to look at it through those two separate ways to evaluate benefits, and then the cost is always going to be about the same. It's the first construction costs, the ongoing maintenance costs, and so on.
Over what time period?
Over it depends on 30 years or 15 years. 30 years is for most residential, actually all residential measures, and 15 years is for all non-residential measures except envelope measures, which are 30 years. This is following a framework that's developed by the California Energy Commission for life cycle cost estimate. We try to meet the California Energy Commission's requirements as much as possible because they're the ultimate ones who are approving these reach codes, right? So yeah, we're trying to meet their framework. Slide 6. Some of the recent work that we've done is at Palo Alto, we helped them implement a 10% reach code. In San Mateo, they wanted to mandate cool roofs and solar PV, so we helped them do that. In Santa Monica, they actually adopted and implemented a zero net energy reach code for low-rise residential on May 1st. And we helped them with that, and we actually had some challenges with the California Energy Commission because the way that we did our cost effectiveness analysis for them was we evaluated every hour that PV was generating with the regular TDV value. And California Energy Commission was kind of with us the whole way, and then towards the end, when they started doing their zero net energy analysis for what they wanted, the policy they wanted to institute in 2020, they realized that zero net energy is going to lead to overcharging because you're compensating, it's going to lead to overgeneration back into the grid because you're compensating for your therms usage, right?
If you use gas.
If you use gas.
Soon to stop.
Right. So what they found that might lead to is a lot of grid problems, and they didn't want to do that. So they realized that PV kind of needs its own separate TDV value, which weren't developed in time for us to do the Santa Monica analysis. So the Santa Monica analysis they approved, but with the caveat that going forward they would like to see it done a different way. Yes.
Not a question. I just want to make a comment related to that. Out of the solar that's out there causing that problem that they're trying to solve, 5 times more of that is utility scale, owned by the utilities, without storage. And yet they're trying to have people building homes to solve that problem. And it's better than to solve that.
Yeah. Yeah. That makes sense. So right now what we're working on is a statewide reach code analysis with Southern California Edison. We're in the final stages of doing the residential zero net electricity analysis, which is where the California Energy Commission is going for 2020. They've dropped zero net energy, they're going zero net electricity. We've been coordinating with this California Energy Commission for over a year about the exact methodology for how to do this. We want to make sure that So this is a statewide analysis. We're doing it for all the climate zones so that any jurisdiction can just use this report and submit that to the California Energy Commission. They don't have to pay for their own analysis. We already completed a non-residential reach code report that had 10 or 15% reach code recommendations for across the state. If you go to,
in that, are you working with heat pumps?
In residential.
Yeah, this analysis, the statewide reach code analysis for SC.
So the measure list is on the next slide. I don't think we actually had heat pumps because we tried to not change the prescriptive system as much as possible. That kind of complicates our analysis more. We have to talk about replacing the system with a different system. That's just more cost research that we need to do. So we try to minimize that type of research. But we do look at heat pumps for the next 2 projects that I'm going to be describing. Yes?
For non-residential, mostly lighting measures like jazz?
So there's a list of 4 different power adjustment factors that are in the non-residential code. Institutional tuning, occupancy sensors in open office spaces. We looked at reducing lighting power density through use of LEDs, which are pretty much market standard anyway, and that's where the code's going to. There was one more. Daylighting dimming plus off. So right now the prescriptive is daylight dims down to 20%. But there's this option in CVEC.com that you could just say it can go all the way off if you need to, and that gets you a little more.
They forgot to turn the lights off.
So this is on slide 7, a list of the single-family measures, and it's the same measures really in multifamily, except the X check boxes are little different by climate zone. So a lot of these are case measures proposed for the 2019 code: quality insulation installation, improved fenestration going down to U factor of 0.3 and SHGC of 0.23, insulated doors, high performance walls, 0.041 U factor. All right, they're going down to R21 high density bat and 2x6 plus R7.5 exterior residential. Yeah, that's gonna be prescriptive.
2 inches?
Yeah. Wow. Yeah. 2 inches is gonna happen. Yeah.
It's just hard to get a nail through it.
Yeah.
It's like, you have to have guide strips and things. It's just so hard.
Yep.
Just means our walls.
Adding 2 inches to a nail, have you ever thought about, it's already a long nail.
Reduced infiltration is one of those measures that you can get credit for in single family. You cannot in low-rise multifamily. It's a 7 ACH50 that's assumed. It's the default in low-rise multifamily. And what we did was we kind of just did some single-family simulations, saw what types of envelope impacts there were, and applied those savings to multifamily buildings because a lot of projects that go for LEED for homes and have HERS raters test those projects, they said, yeah, we can totally get below a 7 ACH50 if you do QII, verified low leakage ducts and conditioned space. This should not, like 5 ACH50 is not hard to get to. So we said, okay, we're just going to award credit for that, and we'll let jurisdictions decide if they want to award credit for that as well. A few different hot water measures, drain water heat recovery I discussed earlier. It's only in the 2,700 square foot house, which is a 2-story building. It's a vertical drain water heat recovery element, so there's only space for it for this particular type. There's horizontal as well, but we only looked at the vertical. There's only space for it in a 2-story house. Reduced span watt draw. I can talk about this for a while, but okay. Next slide. Slide 8 is single-family cost effectiveness. I don't want to spend too much time on this because the next slide kind of summarizes everything, but I just want to show the overall method was that we tried to, in the second column from the left, maximize the compliance margin using the TDV cost effectiveness approach, which is the California Energy Commission's methodology. So we get the highest compliance margin that we can, assess that benefit to cost ratio, make sure it's greater than 1. The only place we couldn't get it greater than 1 was climate zone 7, which has a very, very small energy load.
San Diego.
San Diego.
80% water heat.
Yeah. Exactly.
You can have
uninsulated wall, as long as you have like
Exactly. Live in a tent, yeah. We could get it for multifamily, I think. So then we take those energy efficiency packages. We want to make sure energy efficiency is addressed first. Then we apply PV, which is ridiculously cheap right now. It's something like we used, I think it was $250 per watt after all the incentives for PV, and including 2 inverter replacements over 30 years.
Which slide are we on there?
Slide 8. Okay. So the PV size is kind of in the middle of that slide in terms of kW. And then we look at, punch in the CVEC res hourly outputs into our utility bill calculators, which we have painstakingly made sure that the on-peak, off-peak, mid-peak, non-bypassable charges, baseline credits, all this other stuff is modeled as accurately as we can.
Do you have that as a shareable Excel folder? Because it's always hard, as you know, to set this stuff up.
It's very tough. We're finalizing it with PG&E right now. Everybody else has signed off that our method has been okay. We should ask SCE. They can share it. It's really theirs. Yes.
So when you looked at the packages, one thing jumped out at me is that I don't see that you looked at all at HRVs and reduced HVAC size. So was that something that you considered? Or?
HRVs is something I should have looked at, which I was talking with Luke yesterday. We should have looked at that. There's a big benefit from that, right, Luke?
I only know Climate Zone 4. It's an artifact of TDP, frankly. I mean, it should be encouraged, so I'm glad to see it's a credit. We can talk later about it if you want.
So we might add that in. Reduce HVAC size. The size of the system, at least for cooling, is not something that it's auto-sized, basically. So it's auto-sized. We can't take credit for that. In terms of heating, you can on heat pump systems, but not on furnace systems. So we haven't gone to heat pump systems yet. But I'll be talking about size.
But I mean, you should be able to take advantage of it. Maybe not on the energy side, but on the cost side.
Oh, I see. Yeah. Yes, that's a really good point.
I would think that there's no, because the CC doesn't have a framework for sizing. They refer to ACC manuals. They refer to processes, but there's no like formal limit to how you size the system.
No, I understand that. I'm saying on the energy side, maybe you can't take advantage of downsizing your HVAC system, but on the cost side, you can. So during your benefit cost ratio, you should still be able to see that show up.
So optimally they choose a framework, envelope loads plus bedroom occupants. You could come up with that, right?
Yeah.
You're at 20 minutes.
Good point. I see.
Oh, geez. Okay. All right. So slide 9 is basically our final reach code recommendation measures. It summarizes the compliance margin that we found to be cost effective. This is draft. The compliance margin that we found to be cost effective, and the energy design rating that is including PV to offset the electricity usage that we recommend for a 2016 reach code. Okay. Slide 10 is electrification of space heating and water heating in Palo Alto. So this is a different project, changing gears. Climate Zone 4, City of Palo Alto was trying to find out if electrification of spacing and water heating is cost effective. They have carbon neutral electricity, so they're trying to electrify both new construction and existing buildings. So there's a lot of limitations with this, and I'm just going to kind of skip over this slide for now. So we looked at, and so if you go to slide 12, we looked at replacing the furnaces with heat pump water heaters, replacing gas water heaters with heat pump water heaters, replacing furnaces with heat pump space heaters, and we included the costs of infrastructure upgrades as necessary, or infrastructure cost savings if you're not having natural gas piping or plumbing going through your house. It was a bit of an aggressive assumption because we didn't really look at appliances electrifying, the range and the dryer electrifying, but we kind of just said, well, let's see what the cost impact would be. Slide 13. So the TDD and the on-bill cost effectiveness analysis resulted in the same cost effectiveness result in 61 out of 64 scenarios that we looked at for residential and non-residential new construction and alterations. In summary, heat pump measures in Palo Alto pushed the residential electricity to tier 2 consumption a lot, which really hurt the cost effectiveness. We found that heat pump water heaters cost more than conventional gas and didn't prove enough the software didn't show enough TDD savings as well. However, we did find that heat pump space heaters cost less than gas furnaces, and because you don't have a furnace, it's just an electrical connection. It's a reversible air conditioner, basically. So it's cheaper, we found. and it was mostly cost effective. So the new construction packages that avoid gas infrastructure we did find to be cost effective, which is in this table right here at the bottom. Most of the heat pump water heater measures we did not find to be cost effective.
Even in new construction.
Even in new construction, unfortunately. Yeah.
So, Farhad, I think I asked you this on the call earlier today.
Right.
When you were looking at for new construction, did you include the cost of bringing the gas down the street, bringing it from the street up to the building and putting a meter on there? Did you include those costs?
Yes. So yeah, we subtracted those. So as a package of electrification, we did. But if they were just replacing their heat pump water heater, we assumed that okay, maybe the space heater still does need gas, for example.
Right.
So,
Yeah, I'm talking about new construction.
yes. Yeah, we did look at that, and that's why we got a lot of the packages to be cost effective. Those cost savings from the natural gas.
And I think, correct me if I'm wrong, but the TDD setting was always gas available. So when you're
Correct.
electrifying, you're still being compared to the gas baseline. And we have, I think, had this discussion of if you have the baseline is gas not available.
That's propane.
Well, you have a heat pump as your standard for space heating and space cooling, and so any heat pump looks awesome compared to the federal minimum. And then you have propane for the water, and all heat pump water heaters look better if they're NEA rated, because of that stupid derating down to 2.0 in any other scenario. So a different analysis using that button, different baseline would probably show a different result, is my guess.
Yes,
Although,
definitely, yeah. Definitely.
I think we showed yesterday that tier 2 and tier 3 consumption that you get with the low efficiency building and electrification is pricey, super pricey.
Yeah, no, absolutely, yeah.
As you go up the higher tiers.
Yeah, there's.
Do you think the utilities could fix that? Give us like more electricity in tier 1?
I mean, I think they already do, right?
At least during the winter.
Depends which utilities they do.
It's just not enough to make it cost effective.
I know, but it's and their tiers versus TDD and it's like real world versus compliance world.
They say it's supposed to be 50 or 60%. I think we should be
Yeah.
Another thing that I think doesn't apply to Palo Alto, but applies outside Palo Alto, is if you have hardwired electric heat, then you get a higher baseline. I don't think that applies to Palo Alto. So it makes a big difference outside in, let's say, in investor utility territories.
Okay. So for commercial buildings as well.
No, I think just for residential, because I don't think commercial don't have baseline.
Yeah, that's what I was referring to.
Oh, yeah.
So for instance, I get a baseline double what other people get because I have a heat pump, and people with natural gas get like half the baseline that I do, which makes a very big difference in winter where
Interesting. Right. Yeah.
Where our baseline is larger.
Do you have to, how do you let them know that?
Call them up.
Okay.
Call them up and say I have hardwired electric heat, and they say fine, we will change it.
Oh, wow. Okay.
It's very simple. They just say, oh, thank you.
Huh, okay. I didn't know that.
Do you use electric car
PG&E, it's true for all
rate?
the IOUs.
Is an electric car played in the same way?
Yeah, you can get a different rate.
Cool. Slide 14, I just kind of outlined the code and technical operational barriers. Obviously, Palo 24 compliance modeling has some issues. This general lack of experience that we found in the Palo Alto region from a lot of different stakeholders, but hopefully that changes soon. In terms of commercial applications, restaurants, for example, high temperature, high capacity heat pump systems are not yet widely available that we found. Even a commercial boiler to serve VAV reheat systems, basically a heat pump boiler, was much more expensive than we found. And there was not that much of a big of a market for them. We anticipate barriers will diminish through increased penetration, and we encourage feature analysis to be done because, again, we tried to bound the problem as much as we could, but you can get a lot of different answers depending on what your assumptions are. A comprehensive electrification scenario should really take into account PV, battery storage, electric vehicles, and demand response impacts, and try to come up with a comprehensive cost effectiveness approach. Okay, the last project, slide 15. This is one that we're kind of in the middle of right now, so if you guys have any recommendations about how to go about it or improve it, that'd be great. Heat pump space heating and single family alterations. On slide 16, City of Palo Alto is a client again, and then SMUD is also working with us, and client is on 12. they're basically trying to design incentive programs to replace existing gas furnaces that are near the end of their useful life with heat pump space heating systems. The weird thing is that the existing fuel type, or a natural gas system is the baseline, prescriptive baseline for a replacement heating system. So if a program applicant was to try to participate in one of their incentive programs, they would need to do a performance model to show that a heat pump space heater performs better on a TDV basis than a natural gas system, which is like $300 to $500, and that's a entry barrier to the program, right? So the utilities want to reduce that entry barrier. At the same time, California Energy Commission is saying, well, you need to do the analysis ahead of time to show what combination of capacities and efficiencies are going to be meeting that TDV budget. We're doing that analysis, long story short, and again, these are existing building assumptions. These are existing buildings, so we have 4 different vintages that we're looking at, pre-1978, 1978 to 1992. These are basically big markers of change in the Title 24 code in terms of envelope, mostly, so that these are expected to be different energy consuming type of vintages. We did some research to try to fine-tune or make worst-case assumptions for infiltration rates and leakage rates for the ducts. Slide 17, this is a list of all the different types of inputs that we are running with. And we're basically running all the scenarios right now. It's 14,400 permutations of climate zone, prototype, vintage, efficiency, capacity, ceiling insulation, and duct leakage. So ceiling insulation and duct leakage are the measures that we're considering as low effort efficiency measures that could be paired with heat pump heating. Basically, they're not that costly. So if you want to have a smaller heat pump or a less efficient heat pump because you already have R30 in your ceiling, you should get credit for it, right? So that's why we're adding those 2 measures. Slide 18, these are our preliminary results. So these are the types of tables that we're trying to provide. So along the vertical axis is the heating efficiency. Along the horizontal axis is the heating capacity. So if the intersection of, like, for example, an HSPF 9.5, 30,000 capacity, BTUH capacity unit is green, that means you can install that system and that's prescriptive TDV budget. You're good. If you wanted to downsize that unit to a 24,000 system, then you would at least have to have R30 in your attic. Yes?
So what if someone does a good job and the installer they hire actually does a load calculation for the house and says, well, you only need 18,000 and that's what I'm doing.
Yeah, they don't need us then. If they're already doing the energy
just
consulting.
the load calculation, not energy compliance. So they would still need a Title 24 to do this prescriptive replacement, but that puts them in an awkward place on the chart.
I see what you're saying.
Then they're forced to upgrade things that they don't actually have to upgrade.
Yeah, that's a good point. That's a good point. I'm going to note that. What if I would say if they ask someone to provide a load calculation, I'm not sure how much that costs, but it'll probably be within the range of $300 anyway, $200, $300, which they might as well go do the performance method at that point anyway.
Is there a risk of missizing? You're basically sizing equipment for people using these charts. Is there a risk there? Because what if they have upgraded windows that never came on the radar?
Yeah, no, absolutely. So this is, again, trying to bound a problem with a certain set of assumptions. And I completely agree that what we might risk doing is slightly oversizing these systems. If they had upgraded their windows, for example, we went with worst-case assumptions with each vintage type. At the end of the day, it's like, well, it might be slightly oversized and something we might have to live with.
Oversizing for heat pumps is a positive thing.
Yeah, I mean, it might cost a little bit more, but
because your resistance won't come on as much.
Sorry?
Your electric resistance won't come on.
Yes.
It's the opposite of what you think it would be.
Yes.
And the other thing, Farhad, when you these eras that you have, can you please make sure that 15 and Owen are very clear that those are code? Because you don't want buildings that built in 1978 to assume the same thing as things that built under the code in 1978. This building wouldn't be coming on until after 1980. So this is pre-1978, that means pre-1978 code, and 78 to 92.
Delayed by 2 years or something.
Oh, yeah.
Okay.
You should be clear that that's not the vintage of the building, it's the vintage of the code that was built on.
That's a real world.
Yeah, I appreciate that. Thank you.
I have the residential HVAC programs at Edison, and 3 of the IOUs, the gas company, Edison, and San Diego Gas and Electric, have been advocating residential quality installation program, which is also DOE initiative. And that program is training contractors to do the modeling software on the homes in compliance with ACA 4, ACA 5, and ACA 9, which is the industry standard for right sizing and right sizing of equipment and the right sizing of the ducts and modeling the home. And that way, when you teach the HVAC contractors to model the home, they do a site survey and they take all the windows and the installation, all that into consideration. And so by going down this more prescriptive path, you're teaching an already really failing market. You're teaching the contractors not to do manual J, not to do manual S and D. And so, I'm concerned that we're trying to find, it's a rule of thumb type of approach.
Well, this is retrofits and not new construction, because QII isn't applicable to retrofits unless you open up the walls.
So whether it's new construction or retrofit, you still should be running the manual J.
Yeah. I mean, you can still do a full model. What this is an alternative. This is a prescriptive alternative to full model, so that you're lowering the barriers so that people don't have the expense of hiring the analyst. So the point is that some of these projects that otherwise wouldn't happen at all are able to happen because you've lowered the barriers. But you haven't removed the possibility of doing a model.
The other issue, you should take a look at the report that was just put on PUC's site evaluating compliance and what the issues are that the DNV did. One of the things that jumps out at you in that report is that less than 25% of the stuff that people analyze related to the energy code is actually looked at by building departments. So why ask people to do more and more calculations if the building departments are not even, you won't even find a crease next to the stadium. Why? We need to find other solutions that will actually work.
So I agree with you, Lloyd, that that's the best practice, and that should be done. I would think that in real life, I think on the decarbonization call that we had this discussion on, either the contractor would just go see what the existing capacity is of that system and just replace it with a like for like, because they don't want to risk undersizing a system and having a disappointed client. So it's likely that that old system was undersized, and probably still oversized, I should say, for the building anyway. And that's probably what they would err on the side of oversizing and skip it. That's what we've heard, is they skip the calculation.
It's like 90% of the industry is skipping calculations, and it's a big issue, and oversizing is very, very common, and the airflow is impacted, indoor air quality is impacted, and we end up with tighter and tighter homes. There's a health issue with not properly sizing these systems. So,
I agree.
And you get these short cycles on things when they're oversized.
But unless you use a heat pump, which can just go very efficiently. So Nehemiah Stone is coming up. Thank you, Farhad.
Keep up the good work. So the one you should be looking for is called low income